Now let's recall what I told you last time. We are talking about functions. Functions are building objects in calculus in this course. Okay. For any function to understand the function at elementary level or high school level, you need to be able to answer 4 questions. How to evaluate the function. It means how the function is defined. And then the domain of the function, and then how to graph the function, and then how to get the range of the function, right? The building blocks of all the functions we need are on this list. Now look at the screen on this list. Constant functions, we did question 1a, represented by question 1a. You can understand, you should know how to answer the 4 questions for any constant functions. And then the second class, power functions. Last time we defined power functions. Now let's go over the list first. Okay. So because you do need to know the building blocks. The next class, exponential functions. The fourth class, log functions, and then trig functions, inverse trig functions. Inverse trig functions, I mean. Okay. Altogether, there are 6 classes of the building blocks of all the functions we need. These functions are called basic elementary functions. Okay, we move on to the second class. We defined the power functions last time. Okay, now we go over the properties of 2 particular power functions. Now look at question 2b. Actually, 2b. I think we did 2b last time. We did 2b on Tuesday, right? Okay, I just need to go over 2a. I will go over 2a. I will copy 2a to the PowerPoint, and then we go over the function. Maybe for 2b, I'm going to make some more comments using the new notations, using the interval notation to describe the domain and the range. But now let's do 2b first. Before we do 2b, now let's recall the definition of power function. A power function is a function that can be converted to a function in this form. Here, n is not necessarily a whole number, a counting number. Actually, n can be any real number. N can be any fraction, can be any decimal. Actually, n can be any real number. N can be pi, can be e. So you're going to see e today. Actually, e is a super important number in calculus. Okay, now question 2a on the handout. I'll make it a little bigger. So before we work on the question, the given function is a power function. Now let's recall a power function is in the form of the base is the variable x. So yesterday, some people told me they like white on black. They can see better. I think green on black is probably okay. I don't know. I'll try white. According to definition, a power function is a function in the form of x to some power. The variable is here. It's at the base. Exponent is a constant. Now let's say to some power. The function we are talking about right now is a power function. So because I think I told you 3 formulas yesterday to memorize. So because the function can be rewritten in the form of a power function as x to some constant power, as for the people who were here on Tuesday, anybody want to tell me exponent? This function can be converted to the form of a power function as x to the power of negative 2. I think not all of you guys were here on on Tuesday. The formula I'm using is the following formula. Okay. I do not have time to leave this on screen for too long. Now you take a picture using our phone. You take a picture. These three formulas are going to be very useful for converting some other functions to the form of a power function. Okay. Now, for instance, now we are talking about the function we are talking about now is 1 over x squared. 1 over x squared, in which m value is 2, right? And then you use the first formula. You can convert the function to the form of x to the power of negative 2, right? That's why the function is essentially a power function. Any function that can be rewritten, can be converted to the form of x to a constant power, is called a power function. Okay, so that's a power function. And then for any function, we need to be able to answer 4 questions. How the function is defined, by that how to evaluate the function at different values. We'll work on that first. Okay. Now the solution. We work on some values first. Okay. We just go over the list. The value of the function. That little one is for evaluating the function, and then after evaluating the function, we talk about the domain. Okay. And then we talk about the graph, and then we talk about the range. The value of the function at negative 2. If you want, you can tell me the answer in the meeting chat, please. The value of the function at negative 2. So please, anybody? Value of the function at negative 2. So please, plug negative 2 into the function, replace x with negative 2. Okay, we replace x with negative 2. You have 1 over. Wherever you see x, you replace x with negative 2. You have negative 2 squared. And then you have I'm kind of looking for the final answer. So the final answer is 1 over negative 4. Is that correct? That's not right. I made a horrible mistake on purpose. I'm trying to ask you to avoid the mistake. And also in this course, we like in most cases we like fractions better than decimals. So now let's say if you represent a number like 1/3, 1/3 is accurate. If you convert the number to decimal, you have to write 0.3333, so which is not accurate, right? Okay, the value of the function at negative 2, it means you replace x with negative 2. So the brackets here are essential. Nobody made a mistake in the chat. I'm happy about that. So the brackets here is essential. X is the entire value of negative 2. So do not make that mistake. So that's actually a common mistake. In many cases, the brackets are essential in this case as well. Okay. And then after that, we get the value of the function at negative 1. So just tell me the final answer, please. The value of the function at negative 1 is 1. It's 1 over 1, right? And then the value of the function at 0. The value of the function at 0. Yeah. The value of the function at 0. So do not even write 1 over 0. I'm not the value of the function at 0 is if you replace x with 0. So anybody want to try again? The answer would be 1 over 0. So do you remember 0 is never allowed to be on denominator? 0 is never allowed to be on denominator. 0 is never allowed to be on denominator. By that I mean I do not even want to see that. You just tell me the answer is undefined. The value of the function at 0 is undefined. 0 is never allowed to be on denominator. So this is undefined. Okay? It's not possible. Not possible is good, but a proper term is undefined, not defined. 0 is never allowed to be on denominator. It's undefined. Okay, and then the value of the function at 1, the value of the function at 1 is equal to 1 over 1 squared, so which is 1, right? The value of the function at 2, I believe is 1/4. Okay. The list can be going very long actually. Okay. But if you know how to compute these values, it's fine. Okay. And then we get the domain of the function. The domain of the function. I'll just write it here. For the people who are not here last time, for any function we are doing today, we need to answer 4 questions. How to evaluate the function, how the function is defined. The two things are the same. Okay. And secondly, the domain of the function. The domain of the function is the set consisting of all possible inputs. By that we mean all the x values where the function is defined. It's possible to evaluate the function at what numbers? As I said, the three things are equivalent. Okay, motivated by evaluation, it's possible to evaluate the function at -2, at -1, at -10, at -100, at -1.5, at negative whatever number, right? It's also defined at 1, at 0.2, at any positive number. The function is only undefined. If you look at the function, I'm pretty sure you learned that in high school. It's kind of review class. The function is only undefined at 0. I'm trying to say it's defined at any other number, at any number other than 0. Okay. So the domain. Anybody want to describe the domain in words? In words, please. You can write something in chat, please. Describe the domain in words. The domain is the collection of cannot be 0 and any other number. Okay. Now if you look at the question, we learned the interval notation on Tuesday, right? We learned the interval notation on Tuesday. For all the questions, we are required to write the answer, to write the domain in terms of using the interval notation. I will show you the answer. Okay. The function is defined at any negative number. Using the interval notation, we have an interval like this. So this is the collection, the interval notation for the collection of all the negative numbers. I told you that on Tuesday, right? The function is also defined on at all the numbers, at all the positive numbers, at all the numbers greater than 0. We use a notation like that to indicate that interval. Again, you look at the cursor. I'm doing this for the people who are not here on Tuesday. This is the interval notation for all the negative numbers, the collection of all the negative numbers, the set of all the negative numbers. This is the notation for the set of all the positive numbers. Okay. The function is defined at all negative numbers, at all positive numbers. It's undefined only at 0. Okay. This notation is union notation. The meaning of the union notation is together with. You write the answer like that. If you read the question on the handout, I want you to write the interval write the answer to the domain as an interval or unions of the intervals. So that's what I meant by union. You interpret the meaning of union together with. It means nothing but together with that interval, together with that interval. Okay. Probably you have seen the term union in high school math. I'm not 100% sure. Okay, so we have seen the domain. The second question we need to answer. Okay. The third question is how to graph the function. How to graph the function. If was a real face-to-face class, I would ask people to wave their hands to tell me the shape of the graph. I'm sure you learned this graph in high school. Okay, but the point in here is each value of the function determines a point on the graph. Okay, I will go over that very quickly. Okay. Okay, now you look at the first value. The value of the function at -2 is 1/4. This value determines a point on the graph with x coordinate of -2 and the y coordinate of 1/4. Now we are trying to answer question 3. Okay, how to graph the function. I'm going to repeat my point. Okay, each value of the function determines a point on the graph. On this list, we evaluate the function at a few numbers. Okay. Now, for instance, the first value, the value of the function at -2 is 1/4, or you can say f of -2 is 1/4. This value determines a point with x coordinate of the input is x coordinate, right? -2 and the y coordinate of 1/4. Actually, you do not have to write the point in the solution. But okay, later on I'm going to remove that. Okay, but the second value determines a point with the input is x coordinate, so which is -1. The output is y coordinate, so which is 1. So the point with x coordinate of -1 and the y coordinate of 1 is on the graph. The function is undefined at 0. It means on the graph there is no point with x coordinate of 0. Okay. There's no point above the origin. So just imagine the graph. Okay. And also the point with x coordinate of 1 and y coordinate of 1 is on the graph. 2 1/4 is on the graph. Okay. Do that on scratch paper. Do this. Okay. And then you kind of connect the points. Again, I mentioned that on Tuesday. I will review this. It's possible to evaluate the function at all negative numbers and at all positive numbers. By that we mean it's possible to have many inputs, right? For each input, you have a point on the graph. Corresponding to many inputs, you have many points on the graph. Many points will form a curve in general. This curve is called the graph of the function. I'm doing this for the people who are not here on Tuesday. Okay, I still kind of need points at this point. Okay, on the we call the setup rectangular coordinate system, or rectangular coordinate plane, or Cartesian coordinate plane. I said Cartesian. Cartesian is a name. Okay. You look at the points on the graph. The point with x coordinate of -2, y coordinate of 1/4 is on the graph. It's kind of here, right? And 1 1 is on the graph. The point with x coordinate of -1 and y coordinate of 1 is on the graph. The origin, there's no point on the graph corresponding to the origin, right? And then, so now let's say 1 1 is on the graph, and then 2 1/4 is on the graph. I'm pretty sure you can remember the shape of the graph of the function. It has 2 branches. It's kind of that shape. I will show you the computer sketch very shortly. If you use more inputs to get more points, and then you connect more points, the graph of the function is something like I think I mentioned okay. If you did not know this website, the website is SuperNet actually for curve sketching. Now we are going to sketch the graph of the website. You'll search for decimals. The graph of the function we are trying to sketch is 1 over x squared. Okay. 1 over x squared. That's the computer sketch. The computer sketch of the graph. You'll see a few points. We mentioned a few points, right? The point with x coordinate of 2 and the y coordinate of 1/4. I think 1/4 is here, right? This is a point on the graph we did. That's a point on the graph we did. That's another point on graph we did. I think that's the point. You look at the mouse cursor. That's the point with x coordinate of 1 and y coordinate of 1. We also did the point with x coordinate of 2 and y coordinate of 1/2. I believe it's that point, right? So that's the computer sketch of the function. I showed you the computer sketch. Of course, the graph I drew was ugly, so do not use illustration only. Okay. Now, question number 4. We need to identify the range of the function. Anybody want to tell me the range of the function? In most cases, after getting the graph of the function, it's easy to identify the range of the function. The range of the function is, you look at the graph, you get the collection of all the y coordinates for all the points on the graph. Cannot be 0. Yeah, greater than 0 is better. Interval notation, please. Interval notation. Interval notation, please. We are required to, yeah, something like this. We are required, I think you guys know the interval notation, just it's hard to write infinity, something, right? Number 4 is the range. The range of the function is, again, it's defined as, according to the definition, is the set consisting of all possible outputs. If you look at the graph of the function, you just get all the y values for all the points on the graph. Okay. The range is the interval from 0 to infinity. This notation means the set consisting of all positive numbers. 0 is not in the range. 0 is not in the range. Be careful about that. So we are done question 2. Okay. We did question 2a. We did question 2a. Now 2b. Again, we did 2b last time, mostly, but I will, to complete. I'm going to recall some details. Okay. Partially for the people who are not here on Tuesday. Now look at 2b. 2b, we have square root of x. If you were here last time on Tuesday, I was using that question to introduce many definitions, the domain, the range, the graph, and so on, right? Okay, now I'm going to go over the solution a little quicker. So this time, okay, we evaluate the function at 0 first, the value of the function at 0. If you want to plug in, it means square root of 0, so which is 0, right? Square root of 0 is 0. To get square root of a number, okay, I will show you the meaning of the square root of 4 using the meaning if you forgot. You plug 4 into the function. By that we mean you replace x with 4. You have square root of 4. The meaning of square root of 4 is what number squared is equal to 4. What number squared is 4. What positive number squared is 4. So the value is 2. I was trying to say the meaning of square root of 4. Thank you. And then, sorry, I did not do the values in order. Yeah, that's my problem. I know some people do not like that, but I was trying to mention the meaning square root of 4. Okay. The value of the function at 1 is equal to square root of 1, so which is 1, right? The same as before. The value of the function at -2 is undefined. We cannot take square root of a negative number. No number squared is negative. Undefined, right? Evaluation, how to evaluate the function. We just did that. And then you see the function is defined at all. It's only undefined. It's undefined at all negative numbers. It's defined in inverse. We did last time. Inverse, the function is defined at all the non-negative numbers, all the numbers greater than or equal to 0, using the interval notation. Domain, right? Using the interval notation, it's the set consisting of all the non-negative real numbers, all the numbers greater than or equal to 0. If you use round bracket, you miss one number. 0 is in the domain, right? Yeah, that's right. Okay, and then the graph. We did the graph on Tuesday. Now I'm going to show the computer sketch. Okay, that's the computer sketch of the graph of the function. Okay, and you'll see 1, 1. The origin is on the graph. The origin is on the graph. So because of that value, the value of the function at 0 is equal to 0. The input is 0. That's x coordinate. That's y coordinate. 1, 1 is on the graph. 4, 2 is on the graph. I will show you. 1, 1 is that point, right? 4, 2 is that point. And 9, 3, I believe, is on the graph. You'll see that's point with x coordinate of 9, y coordinate of 3, and so on. Okay. That is the graph of the function. Okay. After getting the graph, we can identify the range of the function. Now let's I just showed you the graph. And then the range of the function. The interval notation again is also from 0 to infinity, right? Okay, we have answered the 4 questions for this particular power function. Again, y is the function of power function. According to definition, any function that can be written or can be converted to the form of x to some constant power is a power function. This is a particular case. The function can be converted to now look at this formula, okay? Square root of x, the default n value is 2. If you do not have to write 2, you write a radical notation. If you do not write anything, the default n value is 2. It means the square root, the second root, however you say it. Okay. Square root of x, it means n value is 2, m value is 1, right? So the function can be converted to the form of x to the power of 1/2, so which is in the form of a power function. I was trying to say the function is a power function because this function is actually the same thing as x to the power of x to the power of 1/2. I mean, okay, exponent is 1/2, the base is x. That's in the form of a power function, right? So rather than this. Later on, you're going to see power functions are super important in this course. It's actually a big class of functions. X squared, you learned before, and many other functions are all power functions, including even the linear function is a power function. It's not precise. Even the linear function in the form of x to the power of 1 is a power function, right? I'm trying to say, now look at that screen. In the future, you need to be, I want you to memorize the graph of all these power functions, okay? Sorry, that's the wrong list. I will give you a new list. The new list is here. I want you to memorize the graph of all these power functions. That's x to the power of 1, a linear function, right? X squared, so populus. I will show you the list on the graphing calculator. So where's my graphing calculator? Is here. I will show you the list. You know this function so well, right? The function y equals x, right? Or f of x is x. A straight line. And then you know x squared. A parabola, right? And then I want you to recall the graph of x cubed, and then we compare if it matches what you remember. That's x cubed. You can use your whatever calculator, whatever graphing tool online to try this, okay? But that's a commonly used power function. You probably want to memorize the graph. Okay. And what else? Square root of x. I just told you square root of x. Okay. I'll look at the list. 1 over x is another popular one. Okay, 1 over x. Now let's get 1 over x. One over x has 2 branches. Okay, that's one branch. Now look at the mouse cursor. Okay, that's another branch. So just memorize the graph of the function. I think for the assignment, we have weekly assignments for the people who were not here on Tuesday. On the assignment, I will give you some power functions for which I want you to answer 4 questions, including the graph of the function. Of course, for the assignment, for any assignment, there's nothing I can do if you use graphing calculator, graphing tool. I showed you square root of x, right? And now I'm going to show you cube root of x. Cube root of x. I kind of forgot about the syntax. Cube root. Yeah, that's it. Cube root. You see, that's cube root of x, right? Again, it's okay if you use a graphing calculator or whatever graphing tool online to get the graph of the functions. Okay, but I want you to remember to memorize the graph of all these power functions. Everything in here is a power function. Yeah, probably you do not have to memorize the last one. You knew many already. You knew the graph of the first one. You knew So this one is a parabola. Okay. I just told you 1 over x and 1 over x squared. You knew square root of x. You don't need to memorize too many things actually. Okay, we're done power functions. I think I'm comfortable to move forward now. Now we move forward to the next class. Things are getting more and more complicated, so don't be scared. I know exponential functions, I think most people can remember a lot of things from the third class at least. Starting from log, I'm going to slow down a little bit. Okay, I will be very slow on tricks, but don't worry. Exponential functions. The first question I want to go over is actually, now look at the definition first. On the screen you have the definition of exponential functions. Okay, it's a function in this form, in the form of this. The base is a constant. The base. Now look at the mouse cursor. The base is a number. The base is a constant. The variable is exponent. X is here. I will make more comments on this. So because I'm actually doing calculus, so later on it's relevant to which formula you want to use to integrate a function, to differentiate a function, and so on. Okay. We're doing calculus. We're doing differentiation, integration stuff. This one is a power function. So because the base is the variable, exponent is a constant, a number, right? Okay. This one is exponential function. The base is a number. 2. Exponent is the variable x. Do you see the difference? Power function, exponential function, power function, right? That's the difference between the two functions. Now we are talking about exponential functions. Okay. Also, I want you to remember the restriction on the base for exponential functions. We only talk about exponential functions when the base is positive number. By that we mean we do not talk about a negative base. The thing could be way more complicated for the purpose of simplifying. The base is not equal to 1. So because 1 to any power is equal to 1, that's too trivial. Okay. Again, there's a restriction on the base. Base is always positive and not equal to 1. Remember that. Now for instance, is 1/4 to the power of x a valid exponential function? The base is now recall the restriction. Okay, the base is positive. The base is not equal to 1. 1/4 is tiny, but it's positive. It's not equal to 1. That's a valid exponential function. That's not valid. 1 to the power of x. That's not a function we're studying here. Okay, so because the base cannot be 1, we mentioned that. Now let's say -2 to the power of x. We do not talk about exponential function like that. We restrict the base to be a positive number, not equal to 1. Okay. Now let's say 100 to the power of x. That's a valid exponential function, right? The point I'm trying to make now is to remember the restriction on the base for any power function. Not equal to 1, greater and positive, greater than 0. After you know that, then we are going to answer 4 questions for for two exponential functions. Actually, the first question I want to go over is not on the handout. Is this one. And by the way, for the people who are not here on Tuesday, the course manual and the handouts are available on D12. So log on to D12. You can get any of these files. For anything on course manual, you do not need to copy. It's always on D12. Okay. For everything I write, my handwriting is ugly. For everything I write, I can write better on Blackboard or whiteboard actually. For anything on my Blackboard, you need to copy. It's kind of your notes. That's exponential function, right? That's a valid one. So because the base is 8, 8 is not equal to 1, 8 is positive, right? And then we talk about how the function is defined. By that we mean we evaluate the function at a few numbers. And then after that we get the domain of the function, we get the graph of the function, we talk about the range of the function. Okay, we answer 4 questions. The value of the function at 0. We replace x with number 0. We have a to the power of 0. Anybody want to tell me this value? A positive number to the power of 0. You do not need to use a calculator. It's always 1. Okay. Any positive number to the power of 0 is equal to 1. It's defined. It's definition. There's a story about that. We don't have time to talk about that story. But at this point, you just remember any positive number to the power of 0 is equal to 1. That's a definition. It's better. And then we get the value of the function at 1. So we plug 1 into the function, of course. So this one is 8. You know that. And then we plug 2 into the function. I'm not doing the values in order. Okay. The value of the function at 2, or f of 2, is 8 to the power of 2. 8 squared. 8 times 8 is 64. And then the value, that's large enough. And then we talk about 8 to some negative powers. Okay. And then the value of the function at -1. We replace x with -1. You have 8 to the power of -1. Anybody want to tell me the answer in fraction, please? I'm looking for answer in fraction. Yeah, 1/8 is right. Here, here you need to recall this formula again. This formula, okay. Where is it? This formula again, okay. You use the formula the other way around. For the people who were here last time, I told you to memorize the formula in 2 ways, right? You use the formula the other way around. X value is 8, m value is -1, m value is 1. Okay, so the answer is 1/8. And then the value of the function at -2, we need to compute a to the power of -2, so which is 1/8 squared. If you use that formula, right, you have 1/16. 1/64. I mean 64. Why did I say 16? That's a horrible mistake, right? 1/64. And then we evaluate 2 other weird values. Okay, I will put the next value in here. So because the value of x is positive, the value of the function at 1/3. Now we are trying to replace x with 1/3. We are trying to compute 8 to the power of 1/3. Now I'm going to make some more. Yeah, 2 is right. 2 is right. 2 is right. But I'm going to make a little bit of comments on these formulas. I told you before to memorize the formulas in 2 ways. One way is from the left to the right. The other way is from to the right to the right to the left, of course. Okay. Why I want you to memorize the formula from the left, from the right to the left? I will try again. Yeah, probably I messed something up. To memorize the formulas from the left hand side to the right hand side, it's useful in terms of converting to a function to the form of a power function. To remember the formulas from the right hand side to the left hand side, in many cases, it's useful when we evaluate the value of a function. Now, for instance, in this particular case, if I'm looking for 8 to the power of 1/3, it's probably a little hard to identify the value, right? But if you convert this to the form of 8 cube root of 8 using the formula the other way around, it's easy to identify the value. Cube root of 8, you think what number cubed? What number cubed is equal to 8? So 2 cubed is 8. So that's how you get the value, right? Ask me if you have any questions. If you have any questions, you can write your question in the meeting chat, or you can speak up. You do not need to raise your hand to speak up in my class. One more. I think one more. The value of the function at negative 1/3. This time we evaluate 8 to the power of negative 1/3. Probably I want to use. I do not have to use negative. I do not have to use brackets. I'll try again. Yeah, that's right. Okay, but I'm slow. I'm going to do it a little slower. Okay, using one of the formulas the other way around. So this one is converted to 1 over a cube root of 8. That's how you get 1/2. Right. Okay, we have seen a few values of the function, right? Quite a few actually. Secondly, you want to try a little while on a piece of paper. Do not use a graphing calculator. Using the point I told you before, each value of the function determines a point on the graph. So maybe try to connect some points and try to imagine the shape of the graph. I will show you the computer sketch very shortly. Now I want you to do something on paper. If you do not remember the graph of the function, probably many of you guys can memorize the graph of this function. If you do not remember, I want you to plot some points and connect points, and then get the graph of the function. I will show the computer sketch very shortly. Okay. Do not use graphing calculator. Do not use anything on internet. I want you to try to plot some point. If you can remember them, probably it's better. Okay. I think in high school you are required to know the graph of the function like this. I think we are trying to sketch the graph. Now I'm showing you the computer sketch. Okay, we are trying to get the graph of 8 to the power of x. You see the graph is here. Okay. Later on, I'm going to summarize some properties of exponential functions. But now I want you to notice that's always a point on the graph. That's the point with x coordinate of 0 and the y coordinate of 1 is always a point on the graph of any exponential function, because any positive number to the power of 0 is equal to 1, right? That's one of the points we have seen, right? Oh, I did not know I can click a point. Yeah, that's nice. And then the value of the function at 2 is 64. I guess you can identify the point. It's far up that way. Far up that way. Okay. Probably we're going to identify some other particular points. Okay. The value of the function at now, for instance, -1 is 1 over 8. That's a point in here. The value of the function at -1 is 1 over 8. That's probably another point. A summary here, right? Summary here. I don't know where. And so on. Anyway, I showed you the computer sketch of the graph. Now, the bottom line, I want you to memorize this kind of the graph. Later on, I'm going to summarize. Okay, the graph of exponential function is kind of that way. And by the way, the computer sketch is never accurate. Now you look at here, the graph of exponential function actually never touches the horizontal axis. Using a proper term, the horizontal axis, x-axis, is actually a horizontal asymptote. You remember the term of the graph. Later in the course, we're going to talk about curve sketching, in which you are going to we're going to use some properties from calculus to study the shape of the graphs of functions. In that place, you are going to have better understanding of asymptotes. Okay. By asymptotes, we mean when x gets larger and larger negative, the graph is getting closer and closer to the horizontal axis, to the horizontal line, but the graph never touches the horizontal line. Okay. Again, later on, I'm going to summarize some properties of exponential functions. At that point, you could have some better understanding, but now I want to finish question first. I just did question number 3, right? I just showed you the graph. Actually, I forgot to mention the domain of the function. So anybody want to tell me the domain of the function? I will ask you to evaluate a few more values. Okay. No, we do not need too many more values. So anybody want to tell me the domain of the function? The function is defined at 1, the function defined at 0, defined at 1/3, defined at 2, defined at any positive numbers and 0. Represented by these values, probably you'll see the function is defined at any negative numbers. Now I'm looking for the domain of the function. Maybe using interval notation, please, if you want to answer the question.
It's from negative infinity to positive infinity.
Yeah, that's right. The domain of the function. The meaning of this notation is the set of all the real numbers, the collection of all the real numbers, the same thing. Right? I showed you the graph already, the computer sketch. I showed you the computer sketch. Easy, right? And then we are going to get the range of the function. After getting the graph of the function, it's easy to identify the range of the function. So anybody want to tell me the range of the function? 0 to infinity. 0 is not included, okay? Because the curve never touches the horizontal axis. 0 is not included. Yeah, round brackets is good. separating a. Yeah, that's good. That's good. So the range is the set consisting of all the positive numbers using the interval notation is something like this, right? So for this function, we have seen how to answer the 4 questions. At elementary level, at high school level, we have understood the function, right? So we did this one. Let me know if you have any questions. And then we move on to question 3a. So look at the base first. So this time the base is 1 over 8. 1 over 8 is qualified as the base, right? Now let's recall the restriction on base. The base is a positive number not equal to 1. 1 over 8 is positive, right? Although it's tiny, not equal to 1, so it's qualified as a base. And then we go over the list of the values. The value of the function at 0. So we are trying to get 1 over 8, the whole thing to the power of 0. By the way, the brackets are essential in here. You know the value is 1. If you want, you can write the answer a little bit before me. The value of the function at 1, I was trying to write the value of the function at 1. We're trying to write 1 over 8 to the power of 1. Super easy, right? So it's 1 over 8. Then the value of the function at 2, 1 over 64. The next one, I'm going to do it a little slower, okay? The value of the function at 1/3. We're trying to compute 1 over 8 to the power of 1/3. I think you can just convert it to cube root of 1 over 8 using one of the 3 formulas I told you before. Okay. You think what the number cubed is equal to 1 over 8? I think you'll see the answer is 1/2, right? And then we go over the value of the function at a few negative numbers. The value of the function at -1. You have 1 over 8 to the power of -1. Anybody want to tell me the answer to this? The value of the function at -1? 1 over 8 to the power of -1. Anything to the power of -1 is reciprocal, right? It's 8. And then the value of the function, yeah, that's right. I think there's a lag between my question and your answer. I'm trying to say the teams may not be in super real time. The value of the function at -2, we're trying to compute 1 over 8 to the power of -2. I think you have 64. 64 is right. If you have any questions, you can stop me at any time, and I can go over the thing in some more details by adding more steps. And then the value of the function at -1/3. At -1/3 is 1 over 8 to the power of -1/3. Yeah, 2 is right. 2 is right. This one is if we are using the formula, it's actually 1 over 8 to the power, so cube root of that, right? So the answer is going to be 1 over 1/2. 1 over 1/2, you know the answer is 2. Okay. Cool. So we know how the function is defined. We know how to evaluate the function. Okay. And then the domain of the function. Secondly, we need to answer. We need to get the domain. Okay. The domain of the function. You'll probably see my voice is getting lower and lower. I don't know. When you sit here and teach, yeah, that's a problem. When you stand there and teach, you keep your voice high all the time. The domain, all the real numbers. You see the function is defined as 0. The function is defined as all positive numbers represented by 1, 2, and 1/3, represented by the inputs value of -1, -2, and -1/3. The function is defined at any negative numbers. So the domain of the function is, again, all the real numbers, the set of all the real numbers. And probably you can imagine the graph of the function using a few points before I show you the computer sketch. You see, the larger the value of x, the smaller the value of y. The larger the inputs, the smaller the outputs. Using a term you learned in high school, the function is decreasing. You remember the term? The larger the inputs, the smaller the outputs. Right. Now, probably you can imagine the graph of the function. I will show you the computer sketch. Okay. So this time we're talking about 1/8 to the power of x. Okay. I don't know what I did. To the power of x. You see the graph is, you see the function is decreasing. That's because from the left to the right, you are going downhill, right? Down a very steep hill. You cannot drive down. I'm pretty sure you cannot drive down this hill. Again, I want you to identify some properties. So later on, I'm going to summarize some properties. This is also a particular point on the graph. The point with x coordinate of 0 and y coordinate of 1, I said earlier, is always on the graph of any exponential function, no matter what the base is. Yeah, probably you want to identify some points, some other points. I mean, when the input is 0, the output is 1. It's a point here. When the input is 1, the output is 1/8. It's probably here. Okay, I'm pretty sure. I don't know. Again, the curve never touches the horizontal axis, and then the function is decreasing. Intuitively, by that we mean from the left to the right, you are going downhill, right? So you got the graph. At this point, you can identify the range of the function. After getting the graph, it's easy to see the range. Again, the range it's kind of all the y values for all the points on the graph. For the graph, my intention is to, if you did not remember the graph, my intention is to get the graph by plotting some points. My intention is not showing you the computer sketch, but the computer sketch is more accurate. And lastly, the range. The range is the set of all the positive numbers, right? So we're done this function, okay. So just copy it down, okay. We have seen the two properties. I just want to summarize something in general. One is there's always a special point on the graph. Now let's recall the point. The point is the point with x coordinate of 0 and the y coordinate of 1. So the point with x coordinate of 0 and the y coordinate of 1 is on the graph. Can I just say always on the graph? Actually, it's a very good habit to always write the restriction on a if we talk about the general exponential function. I meant you write something like a is positive, a is not equal to 1. Secondly, I'm going to summarize when the function is increasing, when the function is decreasing. Represented by 8 to the power of x. If the base is greater than 1, the function is increasing. Represented by 1 over 8 to the power of x. If the base is less than 1, of course it's positive, then the function is decreasing. I'm going to write it down. If the base is greater than 1, represented by 8, I think we did the function 8 to the power of x, right? The function is increasing. I do not have to write the function. I just say f of x is increasing. If the base is in between 0 and 1, the base is positive anyway, right? 1 cannot be a base. There are only two cases for the base, either greater than 1 or between 0 and 1. There are only two cases. The function is decreasing. Again, the meaning of increasing is the larger the inputs, the smaller the. I'll try again. A function is increasing. So by that we mean the larger the inputs, the larger the outputs. Okay. A function is decreasing. It means the larger the inputs, the smaller the outputs. I think I said it right. Graphically, when the function is increasing, you're going uphill from the left to the right. A function is decreasing. Geometrically, it means you're going downhill from the left to the right. Intuitively, of course. Yeah, these are the properties you need to remember. Now let's say if I give you 2 to the power of x, you need to draw a rough sketch. Increasing, passing through a point, you kind of remember the shape of the graph, right? In the future, you should be able to remember the graph of the function and identify some common values. Okay, and then I'm going to introduce a super important number in calculus, e. No matter you learn this number in high school or not, I'm going to introduce the number e. Okay. Okay, now look at the graph of the function. Okay, I will show you. We'll sketch a few graph of exponential functions. I mean, we'll get the graphs of a few exponential functions. Okay. We start from, now let's say some base greater than 1. So can we use 1? Sorry. Can I use 1 pound? Can I start with 1.1? 1.1 to the power of x. That's exponential function passing through a special point in here, right? I'm trying to say if the base is a base like 1.1, how can you describe the shape of the graph? Can we say the graph is kind of flat? It's very flat, right? But the base is 1.1, it's very flat. I'm going to replace the base with some larger numbers. Now let's say with 1.5. With 1.5, it's a little steeper, which is not too steep, right? Now I'm going to now watch me. Watch me changing the base. After I change the base, you observe the change of the graph. Later on, I'm going to motivate a super important number using this. Okay. If I'm replacing the base with 2, it's even steeper. Okay. Okay. Now I'm going to replace the base with 5. It's very steep. It's too steep. Now, the number for the base I'm looking for is a base so that the graph is not too flat, it's not too steep. We'll try. Okay. Now I'm going to replace the base with 3. A little steep, a little too steep, right? I do not like that. If I replace the base with 2, a little flat, I do not like that. Okay, now I'm going to introduce a number e. I'm going to replace the base with e, so very shortly you are going to see the value of e. I think I can type e in here. If I'm replacing the base with the number e, sorry, I need to clear my throat a little bit. Still it's worse. If I'm replacing the base with number e, very shortly I'm going to tell you the value of e. I'm going to use the graph to introduce e. Now you look at the curve. You look at the curve. If I replace the base with the number of e, the graph of the function e to the power of x, exponential function with the base e, the graph of the function is not too steep, it's not too flat. In some sense. Can anybody tell me the sense? So look at this point. In the sense, it's because the graph of any exponential function is passing through that point. The point with x coordinate of 0 and y coordinate of 1. Now I was saying the graph of the function is not too steep, it's not too flat. In what sense in terms of this point? I will give you more hint. In what sense in terms of the tangent line to the graph at this point? So maybe I'm going to sketch the tangent line of the function at this point. I think the tangent line is x plus 1. I will zoom in. I want to repeat. When the base is e, the graph of the exponential function is not too steep, it's not too flat. In what sense? In what sense in terms of the graph, the tangent line? Yeah, it's overlap. Anybody want to tell me the slope of the tangent line? A tangent line, it has to be overlapped. The slope of the tangent line, or this angle, the slope of the tangent line is equal to, answer my question please, the slope of the tangent line is equal to 1. It's equal to 1 over 1. 1 over 1 is 1, right? You got it. I think you got it. Okay. You see, when the base is e, the graph of the function, the red curve, I think it's red. I'm a little colorblind. It's not too bad. I think it's red. The red curve, the graph of the function, is not too steep. It's not too flat in terms of in terms of the slope of the tangent line to the graph of at this point is equal to 1. This line is not too slant either way. It's not too steep. It's not too flat, right? Actually, this is the nicest looking of all the exponential functions. It turns out this value of e is 2.7 something. It's actually comparable to pi. It's an irrational number. It's a infinite non-repeating decimal. It's comparable to pi. Pi is 3.14, so something non-repeating, right? Okay, I'm going to write it down. Probably you want to locate the E button on your calculator. Locate the E button on your calculator. It's either the E button, or EXP button on your calculator. It's kind of so next to natural log. Using that button, I want you to tell me the value of approximate value of E. I want you to compute E to the power of 1. So please, I want you to use your calculator, locate the E button, and tell me approximate value of E by computing E to the power of 1. Anybody want to tell me approximate value of E? Yeah. If you have 2.7 something, that's as far as I can remember. It's something like that. If you get this number, when you compute the E to the power of 1, if you get 2.7 something, then you got the button. Okay. Actually, we rarely use the button, but okay, I'm going to use the graph of exponential function to introduce the super important number E in calculus. You're going to see E over and over again in this course. In any calculus, I mean calculus 1, calculus 2, calculus 3, calculus whatever. You're going to see E over and over again. Okay, I will define the number E. Okay. So this is probably new to some of you guys at least. Okay, E is the real number. The real number. Now copy this down, okay? E is the real number. Having the property that, can I just say such that the tangent line to the graph of the exponential function can I use y equals e to the power of x. Now let me get a little organized. E is the real number such that the tangent line to the graph of the exponential function y equals e to the power of x at the point at the point with x coordinate of 0 and the y coordinate of 1 such that the tangent line to the graph of the exponential function at this point, the tangent line has the slope of has the slope of 1. So maybe a new paragraph. It turns out that the graph is nice, the number is not too nice in terms of it's a weird number. It turns out that E is irrational number. Actually, more precisely, you don't want the term. It's actually a transcendental number. I do not want to make the thing too complicated. Irrational number is it's kind of a non-repeating infinite decimal number. It's comparable to pi. Pi is an irrational number, non-repeating decimal, right? Irrational number. It turns out that E is an irrational number. I think you could write a colon, okay? The number is approximated by that's as far as I can remember the number you got from your calculator, right? Again, the number E is super important in calculus. You are going to see E over and over again, and E has really nice property in calculus. When we do differentiation, integration, you are going to see it. You got the slide? I will move on. Okay. If you didn't get it, you let me know, and I can go back. The next exponential function we're going to study is that a super important exponential function, the most important exponential function in calculus with the base of E. So because the value of E is kind of weird, so I cannot ask you to evaluate too many values. Okay, we just do a few. We just do 3. Okay. Evaluate the function. It means the point on the graph, the point with the x coordinate of 0 and the y coordinate of 1 is on the graph. The value of the function at 1 is e to the power of 1, so which is e. Okay, and then the value of the function at -1, which is e to the power of -1. You do not have to convert the numbers to decimal numbers. You just give me the answer like 1 over e. It's perfectly okay if you give me the answer like 1 over e. For all exponential functions, the domain is the same. The domain is the collection of all the real numbers. Probably I should summarize that too, but I think you know that. The domain is the set of all the real numbers. We have seen the graph of the function. The graph is the red curve. The red curve is the graph of exponential function, e to the power of x, right? the range is also the same. For all exponential functions, the range is always the same. The range is always the set of all the positive numbers. Right. Exponential functions. We're done. Exponential functions. Any questions? Then we move on to logs, the next class. We're done 3 classes already, right? Altogether there are 6 classes. We're halfway done. Actually, we're not quite halfway done yet, of course. The questions are getting more and more weird. Log functions. Probably people are getting a little scared of log functions and trig functions. No worries, it's easy. We'll do log functions first. Okay. Okay, the definition is here. Now look at the screen. On the screen you have the definition of log functions. Very shortly I will introduce the meaning of the logs. I told you earlier, starting from log, I will slow down. At this point, the only thing I want you to remember is the base. The restriction on the base is the same as the restriction for the base on the exponential functions. The base a is here. The base is always positive, not equal to 1. Temporarily, you just remember that. I will talk about how to define a log very slowly when we do questions. Okay. At this point, you do not have to remember the domain and the range even. Later on, I'm going to motivate the domain and the range. We'll work on this question first. On question, I think 4a. That's question 4a on the handout. We'll work on that first. You ready? The first thing we do is to talk about how to evaluate the function. It means how the function is defined. When we talk about the definition of the log function, I will talk about how the log is defined. I will review from there. Okay. The first thing we do is to compute the value of the function at 1. By that we mean you look at the function symbolically. And by the way, you read the function log to the base 2 of x. You read the function log to the base 2 of x. The value of the function at 1, you compute log to the base 2 of 1. The base is always the same. Log to the base 2 of 1. You do not need brackets. That's convention. You do not need brackets. It's okay to write brackets, so there's nothing wrong to use brackets, so like that. But you do not need brackets. No reason. A conversion. It's only a conversion. Okay, now we're going to get this value. I do not want you to remember. I do not want you to use calculator. I'm going to tell you how to get the value. Okay, that's your brain. How you think this is essentially how the log is defined. To get, now listen to me carefully. Okay, concentrate. to get log to the base 2 of 1, you think the base to what power we convert the problem to exponential problem. Okay, I want to repeat. To get log to the base 2 of 1, you think 2 to what power is equal to 1. Anybody want to tell me the value of the question mark? To the number? Yeah, 2 to the power of 0 is 1. We are looking for the question mark having the condition, satisfying the condition that 2 to that power is equal to 1. This will give you the value of the log. This will give you the value of 2 to the power of 2. This will give you the value of log to the base 2 of 1. So the value is 0. You told me it's 0, right? So because 2 to the power of 0 is equal to 1. Actually, that's how we define the log. I'm trying to say in the form of exponent 2 to the power of 0 equal to 1, is that equation is equivalent to log to the base 2 of 1 is equal to 0. These two forms are the same. This is the log form representing the same thing. That's how we define the log. Okay. I told you I would go over the meaning of the log a little slower. Now let's try the next value. Okay. The next one I'm looking for the value of the function at 2. Now we are looking to compute the value of log to the base 2 of 2. Log to the base 2 of 2. This time I'm not going to write on squared paper. Now look at the mouse cursor. You think the base to what power? The base to what power is equal to 2? Is equal to 1. I think you got this. Because the base 2 raised to the power of 1 is equal to 2. Yeah, that's why the log value is 1. Okay, now let's try something more complicated. Okay, the value of the function at 4, we are trying to compute the log to the base 2 of 4. You think 2 raised to what power is equal to 4? Yeah, that's 2. 2 is right. Okay, all of you guys got it, I think. Okay, now let's try something even more complicated. The value of the function at 1/2. We are trying to compute the log to the base 2 of 1/2. At this point, I'm not assuming. Okay, I'm not saying that. Okay, so this time, yeah, you think 2 raised to what power is equal to 1/2? 2 to what power is equal to 1/2? You see it's -1, right? 2 to the power of -1 is equal to 1/2. This will give you the value of the log. So that makes sense? It's -1. Actually, we need a log. So just because in many cases we need to solve some equation for exponent. That's why we need a log. Now let's do a few more. Okay. The value of the function at 1/4. We're trying to get log to the base 2 of 1/4. You think 2 raised to what power is equal to 1/4? It's -2. -2 is right. Okay. We'll do a few more. I'm going to continue to write in here. The value of the function at 0. The value of the function at 0. We think we're trying to compute the log to the base 2 of 0. Log 2 to the base of 0. You think 2 raised to what power is equal to 0? What is the question mark? What is the question mark? To what power is equal to 0? 2 to the power of 0 is equal to 1. 2 to the power of -1 is 1/2. 2 to any power is okay. 2 to the power of 0 is equal to 1. So 0 is not right. Undefined is right. Undefined is right. It can't work. Can't work is good. We say it's undefined. We say it's undefined. Okay. I will tell you why. 2 to any power. This question mark is any power. 2 to any power is positive. It's always positive. You remember the graph of 2 to the power of x is something like this. It's always positive. 2 to whatever power is positive, right? I'm trying to say 2 to no power is equal to 0. 2 to no power is equal to 0. This question mark so does not exist. It means this is undefined. 2 to no power is equal to 0. So this one is undefined. It's comparable to 0 is never allowed to be on denominator. 0 is never allowed to be as a value of any log. So does that make sense? Now let's try one more, okay? Actually, now let's try. I don't know how many more. Now let's try more. Select. Now let's try some more, okay? So anybody want to tell me the value of the function at -1? If you want, I can write log to the base 2 of -1. This time you'll have to use brackets. How do you want to tell me the value of the function at -1? 2 to what power is -1? 2 to any power is positive. 2 to no power is -1, right? This is also undefined. So does that make sense? And likewise, the value of the function at negative whatever thing is undefined. At -100, undefined. This shows you how to compute the log, right? How to compute the log values. Okay. Anybody want to tell me the domain of the function? The domain of the function? Again, I want to recall the domain is the set consisting of all the qualified inputs, all possible inputs. 1 is qualified, 2 is qualified, 4 is qualified, 1/2 is qualified, 1/4 is qualified, 0 is not qualified, -1 is not qualified. Yeah, 0 to infinity is right. Okay. Any positive number is in the domain, 0 to infinity. Okay. The next thing we are going to get the graph. Of course, you can plot some points, but I'm going to show you the computer sketch. Okay. I think I do not need that anymore. Okay. Log to the base 2 of x. This is a graph we are talking about. Okay. You see, you have a special point in here. The point with when x value is 1, y coordinate is 0. We have seen that value. The value of the function at 1 is equal to 0. You have seen that the value of the function at 1 is equal to 0. Right? You look at the cursor. That's a special point. Right. You also see some other weird points. Now, for instance, the value of the function at at 1 is equal to 0. We mentioned that point. The value of the function at 4 is equal to 2. We have mentioned that. The value of the function at 2 is equal to 1. You have that point. Okay. I'm trying to say you connect all the points, you have the graph of the function. Okay. I showed you the graph. Do not forget the graph of a log function. Okay. We're going to use it later in the course. Lastly, the range, please. Using the graph, you can see the range. The range is the set consisting of the y values on the graph. Anybody want to tell me the range? All real numbers. Any numbers in the range. Yeah, that's right. Good. All real numbers. Negative infinity to infinity, right? That's question 8. We'll move on to question B. Okay. After you know question A, so B should not be too hard. The key is actually the key is how the function is defined, how to get the value of the function at different numbers. Right. We'll move on to B. The value of the function at 1, we think we compute the log to the base 1/2 of 1, right? Again, you do not have to use brackets, so, but it's okay to use brackets, I'm trying to say. So this time we try to use brackets. Yeah, the same as before. Anybody want to tell me the value? You think 1/2, that's scratch paper. You think 1/2 to what power is equal to 1? 0, right? And then we evaluate the function at, so maybe 1/2 first. I'm not doing that in order, okay? You compute the log to the base of 1/2 of 1/2. Probably it's a little better to use brackets at this time, so that it's not too messy, at least. You know 1/2 to the power of 1 is equal to 1/2. So yeah, this time you have 1, right? And then we compute the value of the function at, so maybe 1/4 next. So you have log to the base of 1/2 of 1/4. You think you think 1/2 to what power is equal to 1/4? That power will give you the value of the log. This time you have 2, right? Some weird ones. The value of the function at 2, you think log to the base of 1/2 of, we are trying to compute the log to the base 2 of 1, to the base of 1/2 of 2. Log to the base 1/2 of 2. That's what I was trying to say. Anybody want to tell me? Yeah, -1 is right. -1 is right. You think 1/2 to what power is equal to 2? This power will give you the value of the log. So which is what? Which is -1. Very similar to that. The value of the function at 4. We are trying to get the log to the base 1/2 of 4. It's -2. So that makes sense. Okay, so we have seen how to graph the function. To motivate So mute your microphone, please, if you don't have a question, okay? To motivate the domain, I'm going to ask you to compute one other value. The value of the function at 0 is log to the base 1/2 of 0. I think you see it's undefined, right? I was trying to motivate the domain. The domain is kind of the same thing. The domain is Simran. So mute your microphone, please. Gosh. The domain is all the positive numbers. Graph. I will show you the graph. I will show you the computer sketch, okay? I believe you can imagine the shape of the graph. So this time I just replace the base with 1/2. Can I just use 0.5? The same thing, right? 1/2 is the same thing as 0.5. So you see the graph. It's kind of decreasing, okay? As shown. The range, after getting the graph, you see the range is the set of all the real numbers.